This is a video to help you complete your lab properly. And what I'm doing right now is showing you what I wanted you to put on your data sheet. Okay, the data sheet would have a box, or here at least, it has a box. So where I drew the boxes are the places that indicate the products of the reactions that you would be doing. And I wrote them in later for period 1 people. You'll know I wrote this in later because it wasn't there, but I did it outside like this, and these are just the products, but that is not both of the products of the reaction. This is the product that makes the reaction go, and we call it S for solid, which also means precipitate, and that's what this PPTS means. Okay? Here you see the aluminum chromate. Okay, 2 chromates. Oh, that should be 3 aluminums. Ooh, I gotta fix that. Okay, 3 chromates. Oh, goodness. All right, let's get this right. Here we go, 3 chromates. Two aluminums and 3. Well, let's just start over. Al2CrO4 3 times, because aluminum is a 3 plus and chromate is a 2 minus. Okay, so finally got that right. Then the barium sulfate over here is the product of the reaction, and it is a solid. That's what the S down here means, and this kind of got connected to the 4 accidentally. So this is BaSO4. And then the carbon dioxide is a gas. So in each case we have either solid, like for the silver chloride down here, and that means that the S is a solid or a precipitate. The gas is what you would see as bubbles. Does that make sense? Okay, great. Now, what other questions did you have? Okay, the other point of confusion that seems to have come up, and let's get another. So, in the very first reaction that you were supposed to do, where we mixed 1 with 5, I think 1 was lead nitrate, wasn't it? PbNO3. And then 5 was the manganese sulfate. And you'll notice that, oh, I didn't put it in, but this guy is aqueous. All of your reactants are aqueous. Okay? AQ. AQ plus manganese sulfate is going to give you lead sulfate. Lead sulfate is your precipitate. But there's other stuff there. If you look on the left side of your equation, you have lead. Okay, lead's down here, no problem. Nitrate, I don't see any nitrate on the right side, so there has to be another product. Okay, so that other product is the manganese, which also doesn't show up over here. And you'll notice that the first guy in every molecule that is polyatomic is going to be a positive ion, and we always write positive ions first. So we've got manganese, and the manganese here is a 2 plus because sulfate is a 2 minus. Okay, we know it has to be. And that's, this manganese dude is one of those transition elements. So we don't know what he is unless we look at the guy that's with him. And in this particular case, lead is also a transition element and can be several different charges. So we look at nitrate, and we see that there's 2 nitrates. Each one has a 1 minus charge. So lead has to be a 2 plus. So basically what that means is, whether we have lead or manganese, we will have, when we put the nitrate with the manganese, 2 of them. Not because there's 2 on the left, but because the manganese and the lead both wind up with exactly the same charge. Okay? And that's how we know what they are going to be on the other side, because in these reactions, charges will never change. Okay? So we've got our solid now and another aqueous product. Okay, I'm going to do the second one for you as well, because I want everybody at home who's watching this to be able to see at least two examples of what it is you're supposed to do. So I'm going to put another page in here, and I'm also going to need a little pointer for this one, and I'm going to write the reaction and then I'll come back online. Okay, here's your second reaction. This was 8 with 3. 8 is our potassium chromate right here, and 3 is aluminum sulfate. Okay, where do we get this information? It's off that sheet I gave you in class today. Okay, so I gave you during class the aluminum chromate, which is your product that winds up being a solid. And let's get that S in there. And this guy is aqueous. I didn't get that in there. All right, now what's that last part going to be? Well, for this guy, we have aluminum from here, and we have chromate from here. So that became our solid. Now we have to figure out, do we have potassium? I don't see potassium here. Well, potassium has to be on the right side of the equation because we can't create or destroy matter, right? Oh, okay. So we're going to have potassium here, and who's he going to be with? He's going to be with the sulfate that is also missing from this molecule. Okay? So the sulfate comes over, and he's going to be SO4 has a 2- charge, and potassium has a 1+. So these guys go together in a 2-to-1 ratio. Don't get snookered by thinking that this is a 2-to-4 ratio, because 4 is the number of oxygens hooked to the sulfur. Okay? So now we have our skeleton equation, and from there we're going to balance. And for all your reactions, you need to have that T-chart. And I'm going to make a T-chart just for this guy, so you can remember how to do it. Potassium is the first guy I see up here as I go from left to right in my equation. So I put potassium. He has to be on both sides. And then I'm going to balance with chromate. I'm not going to balance chromiums and oxygens. No way. Okay? It just makes life really hard. So I'm going to put CrO4. And he's going to be our second one, CrO4. And you can see we're going to have 4 reactants and 4 products. Okay, so we're going to go to aluminum next. That's how I'm making this little list. And then the last thing we do is the sulfate, and that's on both sides. SO4. So I'm balancing with my polyatomic ions now. So I look over here, I see I have 2 potassiums, and without doing anything, I wind up, luckily, with 2 potassiums on the right. So far I'm balanced. Okay, chromate. I have only 1 on the right, or on the left, I'm sorry, and the chromates on the right are 3. Now we have a fly in the ointment. So we're going to have to fix things. Because we have the 3 over here on the right, because of this subscript, I got to have 3 of these guys up here, which I can only affect by putting a 3 here. When I did that, and here, let's do the balancing in a different color. once I do that, I have messed up my chromates, or the chromates are in balance now, because I have 3 chromates here and 3 over here. But the potassium's just changed also. So I have 3 times 2 potassiums, and I'm going to cross that out. And 3 times 2 is 6. And so how am I going to get 6 on the right side? What's my coefficient have to be to get 6? Right, because if I put a 2 here, let's do it in red, a 2 here, now the 2 times 3 is 6. And so I have 6 chromates on the left and 6 on the right. Okay, let's go for our aluminum now. Aluminum, we have how many on the left? 2. So 2 aluminums here, and how many aluminums on the right side? Yeah, 4. And that's 2, the coefficient, times the subscript, 2 times 2. So that's 4. So I have 4 over here, 4 aluminums. So I got to cross that out, and let's see how I can get 4 aluminums on the left side. I'm going to multiply by 2, I sure am. So we got a 2 there. And now I have 4 aluminums on the right, but I just changed the number of sulfates, didn't I? Okay, and to change the number of sulfates, I've got to go to the coefficient of potassium sulfate, and to get, oh wait. I stopped the recording because I realized that I'm not going to get my sulfates to balance, and there was a reason for it. I missed on my coefficient here on the potassium sulfate. So when I changed this back to a 3, that gave me 3 times 2 is 6 potassium instead of 6 times 2, which is 12. Okay, so 2 times 3 is 6 potassium, and 3 times 2 is 6 potassium. And then I have 3 sulfates here, and the aluminum, that gave us 3 times 2 is 6. So, still got a problem. Okay, I got off because I messed up with something earlier. Let's go back and count this out now, one at a time. 6 times 2 for potassium gives me 12 potassium on the left. And 6 times 2 potassium on the other side also gives us 12. Okay, so I've got 12 potassium here, 6 times 2. I've got 12 potassium here, 6 times 2 is 12. I've got 6 chromates here, and over here I have 3 times 2 is 6 chromates. So chromates are good. Aluminums are 2 times 2, which is 4. So this guy has got to be a 4 now. And the aluminums on the right are 2 times 2, or 4. Sulfates, 3 times 2 is 6. And sulfate, 1 time, this is 1, not 4. 4 oxygens with the sulfur. So this is 6 times 1 unit called sulfate, and that gives us 6 of those sulfates. So we got 6 sulfates on each side, and now we are finally settled in, and we balance on both sides. Anyway, this T-chart got me on the right straight and narrow, so that I got it right. And as you can see, I make mistakes too, and I can fix them, especially when I do this. So be sure you do those little T-charts. They're very, very important. I hope this gets you 100% on your lab, and I think we're good. So